We present here MakeEmPay, our solution to the FTC Robocall challenge. Our solution uses virtual currency that we call FTC dollars. This currency is used as a way to keep track of the reputation associated with each phone number. Normal users don't need to understand what FTC dollars are or even know that they exist. This approach doesn't cost regular users anything under normal usage patterns. It only affects robocallers in that it makes their calls expensive. In the basic version of our solution, a set of servers hosted by the FTC keep a monthly calling budget for each known phone number. The FTC servers can be replicated in a manner similar to DNS servers. The budget for every number is initialized to be FTC dollars at the beginning of each month. Now let's say Joe Bob wants to make a phone call to Mary Jane. Before connecting Joe Bob's call, Mary Jane's service provider first checks with the FTC server to see if Joe Bob's account has sufficient budget. The FTC server finds that Joe Bob's account does indeed have adequate budget and replies back to the service provider. At this point, the service provider goes ahead and connects Joe Bob's call to Mary Jane. Now let's say Mary Jane likes to talk to Joe Bob, and so they chat for a while. So after their call ends, Mary Jane's service provider informs the FTC server that this call was good, that it was not flagged. And so as a result, Joe Bob's budget is incremented, in this case by 10 FTC dollars. Now let's see what happens when Robocaller 1 calls Mary Jane. Again, Mary Jane's service provider will first check with the FTC server to see if Robocaller 1 has sufficient budget. The FTC server will reply back saying Robocaller 1 does indeed have adequate budget, and so the service provider will connect Robocaller 1's call to Mary Jane. However, when Mary Jane realizes that it is a robocall, she'll either press a predetermined sequence on her phone like #666, or simply hang up the phone within a short time, say T seconds, which is a signal that the call is likely a robocall. So this makes her service provider flag the call, and so after the call ends, her service provider informs the FTC server that the call was flagged, and so Robocaller 1's budget decreases, in this case by 5 FTC dollars. So in the future, let's say Robocaller 1 tries to call Sally Ann, and so again Sally Ann's service provider checks with the FTC server to see if Robocaller 1 has sufficient budget. But this time, Robocaller 1's calling budget is 0, and so the service provider will terminate the call. In general, if a caller's budget is depleted, their future calls could be made more expensive, or they could be asked to complete a CAPTCHA before each call, and so forth. A limitation of the basic approach that we just described is that robocallers can set up receiving phone banks which are used to replenish FTC dollars, so they can use those dollars to continue making illegal calls to honest users. So Robocaller 1 may call Robocaller 2 and keep the call alive for long enough so that the FTC server does not flag it, and therefore this adds to Robocaller 1's budget. And so Robocaller 1 can keep doing this every time it needs more budget. This limitation of this basic approach that we just described can be overcome by incorporating a credit network into our model. Credit networks are based on mutual trust between numbers instead of a global notion of trust. In this approach, the FTC server stores a calling budget for every pair of phone numbers. The arrow from Bob to Alice means Bob trusts Alice, and so Alice can call Bob. Similarly, Carol trusts Bob, and therefore Bob can call Carol. So by transitivity, we allow Alice to make a call to Carol. In general, a call is connected if there exists a path of trust from the callee to the caller. If the call is good, we create a new trust link from Carol to Alice and initialize it with some budget. However, if the call gets flagged, the budgets along each link in the path decrease, although the edges closer to the caller take a greater hit. This approach doesn't suffer from the limitation outlined for the basic approach. It might seem that computing these paths of trust in the network is computationally expensive. However, recent work has shown that it is no harder than finding shortest paths in the network, which can be done pretty efficiently at scale using modern computing infrastructure.